the purpose of boring operation in relation to a drilling operation is to, okay, what is the purpose of this? So you see, generally drilling operation, so drilling operation, for example, if you take any plate like this, so drilling operation initially make a hole here, it will make a hole like this, okay, and after making the hole, boring operation, boring is like it will further enlarge it, okay. After enlarging that, internal surface should be finished. So for that we will use the other processes. What are those? Those are reaming and honing, okay. So here you need to remember this. These are a simple thing, but unless otherwise you don't remember this. Only mechanical students can answer this, okay. So what is the answer here? Answer is enlarging. So option is D. So the fatigue resistance of materials can be improved by. So first one is the short peening, and next one is the polishing in the surface. Okay. So first of all, what is the fatigue resistance? Fatigue. What is the fatigue? Fatigue is it is a failure because of the reversible stresses. For example, if you take the shaft in the car. So shaft in the car means the wheel axle. Then what is happening? There are some forces acting on this in the transverse direction, that means perpendicular to this axis, and this shaft is continuously rotating. Okay, so what is happening? We have seen when we are dealing the bending stresses. Okay, so when you applied some force transverse to this, then what is happening? Okay, so if it is like a simply supported beam. When it is a simply supported beam, then what is happening? Sometimes the bottom fiber is experiencing the tensile, and the top one is a compressive. So if the shaft is not rotating, then what is happening here? Every time the top one remains experience the compressive, and the bottom one keep on experience the tensile stress. But what is happening after some time? This lower fiber will go to the top, and top fiber will come to the bottom. Okay, it is rotating, so they keep on changing. The fibers will change their position. They keep on change. Okay, because it is rotating. That means sometimes it is experiencing the maximum tensile stress, and sometimes it is experiencing the maximum compressive stress. So repeatedly it is experiencing. That means it is experiencing the cyclic stress. So whenever some material is experiencing the cyclic stress, then after some time, it will reach its it will fail because of that. When it reaches its limit. Okay, so that is called as the fatigue. So how to increase the resistance to this fatigue failure? Okay, so one is a short peening. So what is the meaning of the short peening? What is the meaning of the peening? If you see the meaning itself, you need to know peening, the English word. So what is the meaning of the peening? Peening is nothing but if you take any surface, so if you slowly hammer it with a spherical. Generally, if you slowly hammer with a hammer on the surface, generally we will take the some spherical balls like this, and then we hammer this like this. We hammer on the surface slowly. So what is why we are hammering that? Because of hammering on the surface, then what is happening? Little bit small dents will happen. That means it is going into the surface like this. Then it is forming the compressive portion there. So it is producing some compressive stresses, the residual stresses. Why we are producing that? Okay. For example, I will tell one simple thing, like I have taken a very hard rubber. I mean, it can be extensible, but very hard rubber. So I will make some experiment, like I will stretch the rubber, and with a sharp object I try to cut it. Then it is very easy to cut that rubber when it is a stretch. That means when it is subject to the tensile, then it is easy to break it. Okay. So instead what I do is the same rubber I try to compress it. When I compress it and if I use the same object with the same force, same sharp object to cut that, then it is not so easy. Okay, that means the compressive stress, the failure in the compressive stress is not so easy compared to the tensile stress. Okay, that is why here we are artificially producing some compressive residual stresses here, compressive stress, so that the failure will be reduced. Okay, that is what here we are doing the short peening. Okay, and what are the other techniques that we can use? That is polishing the surface, So why polishing the surface? See, most of the cracks in the fatigue, what happened most of the time, because of this continuous reversible stresses, generally the crack will form. Okay, the crack will form, and the possibility of starting this crack on the surface is more compared to the inside of the material. Why? Surface is always exposed to the atmosphere, and even if some small dent or a little bit void happens there, then immediately the crack will start forming there, and it will easily generate inside. Okay, instead of that, if you make the surface very polished, so without any cracks, then what happens? The possibility decreases. That is why by polishing the surface, you can reduce the formation of the fatigue here. Okay, what are the other techniques that you can reduce the fatigue? Actually, fatigue also happens because of the stress concentration factor. So I'm not going to explain what is that. You listen to our video lectures. So how to reduce the stress concentration? If you decrease the stress concentration effect, then in that case also you can increase the fatigue resistance. How to do that? For example, if you have a sharp edges like that in a body. Okay, then what happened? It is like a flow theory. So all of a sudden the stress concentration increases. So instead of having this, you can do like this. Okay, you can try to have something like this. Otherwise, here if you have a very big notch, then the concentration also very much high. So instead of having very big notch at one place, I can have a very small notches, so that uniformly it will be distributed. Okay, so all these techniques will reduce the probability of fatigue and increases the resistance to the fatigue. So what is the answer here? Both are correct here. So option is C here. So next one is assertion and reasoning. So statement 1, the gap between potential energy of spring versus the extension or a compression of the spring is a straight line. Okay, so the statement 2 is the potential energy of a stretched or compressed spring is directly proportional to square of the extension or compression. Okay, so we will see these statements. So first of all, what is the potential energy of a spring? You see, generally most of the cases, unless otherwise it is mentioned that spring is having some mass, we generally neglect the spring mass. Okay, so for when the spring is stretched or compressed, then what is the force? Force equal to K into X. So where X is either compression or expansion, and K is the spring constant. Okay, it is in the Newton per meter or kilonewton per meter. So this is the force, and generally there are KE and PE. What is the KE? KE generally here, KE is depending on the mass of m square. Okay, even potential energy also mgh or something like that. So here mass is neglected most of the time, so we have the total energy which is equal to the potential energy. So here what is happening? KE plus PE equal to total energy of the spring, and K is neglected because the mass is neglected here. So PE will become total energy here. So total energy, how to find out the total energy? What is the energy here? Total energy is nothing but a strain energy here. Strain energy means what is the energy of the spring? For example, if I compress the spring, what is happening? When compressing the spring, you are giving force externally to the spring. then it will take the all the force, and whenever you remove the external force, then what happens, spring will jump like this. How it is jumping? Okay, from where it is getting that energy? The strain energy is stored internally. Sometimes it is also called as internal energy of the spring. So as soon as you remove the restriction, then it is jumping, the spring. Okay, that means the energy to strain the spring is stored in that, and then it is nothing but this potential energy or a total energy in this case. Okay, so how to find out that? See here, this is the spring, and I am stretching it by applying some force here, and which is saving in the spring as a strain energy. So when I applied the force here, initially the displacement is 0. After some time the displacement is x. Okay, so for the applied force F, how much it is stretched? It is stretched from 0 to x, and I will take the average. So average of x by 2 into f. Okay, so it is something like a fx of fx, and f is a k into x, so half k x square. This is nothing but a potential energy. So the potential energy of the spring is half k into x square, where x is either compression or extension of the spring. Okay, so this is the potential energy. Here from this formula, what is that? Potential energy is if generally K is a constant for the given material. Okay, this is the material property, spring's constant. Okay, for example, steel is having a more spring constant. If you take the rubber, its a spring constant is very, very less. Okay, so here potential energy is proportional to the square of the compression or expansion. So if you look at the statement 2, that is correct. And if I draw the graph between potential energy and strain energy, then it is like a parabola. Okay, so it is like a parabola like this. So it is not a linear graph. Okay, so statement 1 is wrong. So here statement 1 is wrong and statement 2 is correct. So what is the option here? Option is D here. And next question is 10. Statement 1, the fatigue failure is a stress which is lower than the yield strength of the metal. Okay, and statement 2 is repeated straining lowers the yield strength. Okay, so what is the meaning of that? See, for example, what is the fatigue stress here? Fatigue stress means the same portion repeatedly subjected to the tensile and as well as the compressive force. Okay, so repeatedly it is subjected to the straining. You imagine, it is totally changing from a tensile to the extreme compression and from extreme compression to the extreme tension. That means it is subjected to a lot of straining. Straining in the sense means it is subjected to the compression and expansion like that. Okay, because of that, what is happening? Generally, if the body is subjected to the only tension, for example, only tension without a reversible forces, then what is happening? For example, it will fail at a sigma yield. It will fail at yield. Or generally, if it is subjected to the only compression, then it will fail at a sigma yc, sigma yt. Okay, and generally sigma yc is greater than sigma yt. But what is happening here? It is subjected to too much of stresses. Too much of stresses in the sense, repeated reversible stresses from tension to compression, compression to tension. Then what is happening? Generally, we think that, when the material reaches its yield point, then only it will fail. Okay, yield means, its maximum limit. But because of this reversible thing, what is happening? Continuous reversible straining, the failure will occur even below this point. Okay. In case of the fatigue, the failure of the material happen even below the, it's a stated yield. That this point is very much important. This point is very much important. Why? Because see, there are two types of stresses. We see that. What is that? Static and dynamic. So what is the static and what is the dynamic? In case of static, for example, if you take the column in the if you take any column in our building, it is static. The force whichever acting on this always static. Or if you take any beam, in the building, always forces are acting here, and it is static. Those nature of the force is not changing. What is the nature? It is not changing from tensile to compressive or compressive to tensile. It is not changing. But whereas if you take the dynamic, for example, especially in the moving components, like in the automobile, I already explained, if you take the wheel axle, then it is continuously rotating because of its rotation, and at the same time the transverse forces that are acting perpendicular to the length of the beam. What is happening? Every fiber is continuously subjected to the stress, and as well as the tensile stress, and as well as the compressive stress. Okay, so if you try to use the same technique that you use for the static application, and if you use the same technique for the dynamic application, whichever you use for the static, then it may fail. Okay, it may fail. It may fail even beyond your prediction, even much below your prediction. Okay, that is why always you need to consider the dynamic theory also, like fatigue calculation for the moving parts. Okay, otherwise if you use the same static calculation, then it will fail much below the predicted value. Okay, so statement 2 is the correct explanation for this statement 1. So what is the answer? Answer is here.